this series of videos, we're going to be looking at linear equations in two variables, or those entities which are sometimes called linear functions. You remember from your work with linear equations in two variables, every linear equation in two variables can be put into this form, y equals mx plus b. You remember what that form is called. That's the slope-intercept form. And that's because when you have the equation in this form, the m value, the coefficient of the x term, is the slope of the line that is related to that equation, and the b value here, the constant, is the y-intercept. Y-intercept, again, being the point where the line would cross the y-axis. So if we have an example of a linear equation in two variables, say the equation y equals 2x plus 3. In this case, the line that is related to this equation would have a slope of 2 and would have a y-intercept of 3. It would cross the y-axis where y is 3 and x is always 0 on the y-axis. So from this equation, we know the slope is 2, and one point on the line would be the point 0, 3, the y-intercept. If we wanted to find other points on the line, we could simply give a value to x, and then we would find the related value for y. In this instance, the y value depends upon what we put in for x. The y value is related to x. It depends upon what we put in for x. So in effect, here we have a linear equation where the y value is related to the x value. The y value is a function of the x value. The x value we put in determines the y value that we produce. So if I let x be 1, 2 times 1 is 2, 2 plus 3 is 5. So if x is 1, the related y value is 5, and that gives us another point that would be on our line. If we let x be negative 2, 2 times negative 2 is negative 4. Negative 4 plus 3 is 1. So if x is negative 2, the corresponding, the related y value is 1. So the y value is produced by picking some value to put in for x. And these are things that you've worked with. You've worked with linear equations in two variables. And perhaps you've even talked about them as being linear functions. Remember the idea of a function? The idea of a function is that for a value of x that you put in, it will only produce one value of y. You will not have a situation where one value of x would be related to two different values of y. And that's the case we have here when we have this linear relationship. An x value will only be related to one y value, or one function value. And mathematicians adopt this special notation of choosing a letter. Typically they use the letter F. Sometimes they'll use a letter that's kind of indicative of the subject you're talking about. But just in an abstract fashion, they use the letter F for function and follow it with parentheses with the x inside the parentheses. And this is read a function of x. But remember, the f of x is really just replacing the idea of y as a variable. The y value is a function of x, and that's what this says. The value here is a function of what you put in for x. And remember the idea, f at 3 means you would put a 3 in place of x and do the arithmetic, and that would tell you the function value. 2 times 3 is 6, 6 plus 3 is 9. So when x is given a value of 3, the y value, the function value, is 9. So it's just another way of talking about a linear equation in two variables. but identifying that it's that special relationship where a given value of x will only produce one value of y. That's the concept of a function. Not all equations define functions, so when we do have an equation that defines a function, we adopt this special notation. Now, let's look at some applications of these linear functions.